pro- will proceed in innovative approach in calculus, and we will see differential aspect of proving the sin x. Okay, amazing, mind blowing. Different, we will prove different aspect of proving the sin x. I mean, it's clear, right? Means if I have, it's clear, right? That if I know integration of something, then reverse is differentiation. If I know differentiation of something, then reverse is integration. Okay, anyway, now we have found that integration of sin x is minus cos x. What is the differentiation of cos x? Then differentiation of cos x is minus sin x. Very nice. Okay, what about calculating the differentiation of sin x or sin theta? Okay, same way, the way what we did differentiation of sin theta. Okay, anyone would say differentiation of sin theta. Okay, someone can try differentiation of sin theta. How someone would get differentiation of sin theta? Okay, through first principle, the differentiation of sin theta is nothing but sin theta plus delta theta minus sin theta by delta theta. This is the first principle in differentiation. Sin theta, many times we have talked what is differentiation. Okay, if I have a curve, okay, I'm not going to unfold it. Okay, so consider this is a circle, and circle is centered at the origin. This is a circle, and circle is centered at the origin. If circle is centered at the origin, then this is x-axis. X-axis, this one end is origin. This is x-axis or this is x-axis. If that is the case, then what is the equation of the circle? Equation of the circle is x square plus y square equal to a square. X square plus y square equal to a square. What is y? Are they independent to each other? Certainly not. They are not independent to each other, x and y. Y equal to square root of a square minus x square. Means if I keep changing x and make a function over x as a square root of a square minus x square, it gives me different y. If I take different x and calculate at different x, calculate new y, then it gives me x comma y separate point. If I connect all the x comma point y point on xy plane, it gives me the circle. What is dy by dx? Dy by dx means if this is x-axis and I take any point on x-axis at x1, at this x1, what is the function over x1? So function over x1 is y, that is square root of a square minus x square. So at x1 the height is square root of a square minus x1 square. Differentiation means if I take any point x1, see what is the y. Take another point x2 and see what is the y. If I move x1 to x2, how much y change? Okay, so if this is a circle centered at the origin, if I take any point x1, then height is this. If I take x2, then height is little less. This much is the shift I see in height when there is a shift from x1 to x2. If there is a shift from x1 to x2, height shifted from this point to this point. So if so dy by dx, differentiation of y with respect to x at what point? Every point this dy by dx is change in y with respect to one unit change in x. One unit change in x. If there is one unit of change in x, then how many unit of change that is seen in y? If there is a x2 minus x1 unit of change has happened, then if I divide y, then it will bring the per unit change. Makes sense, right? If I go, if I have x1 and x2, x1 is 3 and x2 is 6, x1 is 3 and x2 is 6. For x1, y is 10 and x2 is 50. I'm increasing 50. Then what is dy by dx when x equal to 3? 50 minus 10 is 40. And here 6 by minus 3 is 3. 40 by 3, or let's take it is 10 and 40. At x1 the y is 10 and x2 y is x2 y is 40. Okay, if that is the case, then 40 minus 10, 30 by 3, 10. 10 means if there is one unit of change from point x1, at that moment, someone can see 10 change in y. So, if this proves that x2 minus x1 should be as small as possible so that we can calculate the differentiation at point x equal to x1. This should be very, very small, very, very small. So that is now at x1, what is the y? That is function over x at point x equal to x1 or fx1. At x2, what is the y? fx2. fx2 minus fx1 divided by x2 minus x1. Considering x2 minus x1 is very, very small. That's why we are thinking that we are at point x equal to x1 only. The primitive calculus says that don't take delta, delta, and those kind of things. Try to prove algebraically only rather than taking delta. So whatever the first principle say, if I am calculating sine d sine theta by d theta, d sine theta by d theta, d sine theta by d theta. Okay, so if I have x axis as theta, then for every theta there is a height. That height belongs to sine theta. So consider this is the origin. When theta equal to 0, then sine theta is also 0. When theta is pi by 2, then height is sine pi by 2. When, when theta is okay, the way we are growing, the height is nothing but sine of the theta, where theta is in radian, and that is along the x-axis. If that is the case, then at any point theta equal to theta 1, at any point theta equal to theta 1, what is d sine theta by d theta? That is the question. Means if I take any point theta equal to theta 1, at that point what is sine theta 1? Now from theta 1, if I make a small change, one unit, as I say, or 1 unit can be 1 millimeter, 1 picometer, 1 micrometer, depends upon what unit we are taking. So if I make 1 unit change from the theta 1, how many unit change I see in the y direction? D sine theta by d theta at theta equal to theta 1. At every theta value, different value, this d sine theta by d theta would change. Then how I can say it is generic d sine theta by d theta? D sine theta by d theta, if sine theta is algebraic, then result will come as algebraic only. If result comes algebraic, means now whatever the result comes as differentiation, if it is algebra, keep changing theta and keep getting the differentiation at different value of theta. Mind blowing, right? Very nice. So d sine theta by d theta is d sine theta plus delta theta minus sine theta by delta theta. So d theta plus sine theta is sine theta cos delta theta minus sine delta theta cos theta minus sine theta by delta theta. Sine theta cos delta theta tends to 0. Then it is 1. Then sine theta gone. Cos sine delta theta cos sine delta sine I mean okay, sine delta theta cos theta minus sine delta theta cos theta, I'm sorry, plus sine delta theta cos theta by delta theta. Cos theta I can keep outside. Sin delta theta by delta theta equal to 1 when delta theta tends to 0. If delta theta tends to 0, sin delta theta, sin delta theta tends to delta theta only. Then it becomes delta theta by delta theta 1. So differentiation of sin theta is cos theta. What it means? We will go by our trigonometric proof. What it means? The differentiation of sin. What is differentiation of sin theta? The differentiation of sin theta is cos theta. Very nice. What it means? I don't know what it means. But through through mathematical equation, this is what I have found. The differentiation of sin theta is cos theta. Okay, but I have learned the differentiation vary with different theta value. At every theta value, the rate of change means if I move 1 unit along the theta, then how much the fx or sine theta is changing. That is not that change with 1 unit change at any point is not same. Where it is same, it is same when I have a straight line. If I have a straight line and this is x-axis, then any point you take and see the y, if you move 1 unit, then whatever the change in y is seen. I take any point here and then take y, I make 1 unit change, same unit will change here also. But in case of sine theta, okay, now I'm going to take it out. But in case of sine theta is like this. This left hand is origin. Sine theta is like this. Now, if it is like this, then this is x-axis. At any moment, if I calculate y and then I move 1 unit and see the change in y, that is d sine theta by d theta at this point. Now, if I go another point and take y and I move 1 unit and see another y, and if there would see the difference and this difference will be different. Different means differentiation of sine theta at every theta angle is not same. It is typically a non-linear electronic circuit. Okay, if that is the case, then what is the differentiation? If I try to find differentiation at any point, then it will be algebra again, so that you keep changing the value of theta and keep getting new differentiation. That is cos theta. What is differentiation of sine theta when theta equal to 0? Means when theta equal to 0, means if this is the sine theta curve, the position it is crossing the x-axis, this is pi, it is pi. Maximum it is going at pi by 2. Minimum it is going at 3 pi by 2. It is coming back at 0 here when 2 pi. If that is the case, what is the differentiation of sine theta when angle is 0? Here, that is cos theta. What is cos theta equal to 0? Theta equal to 0. 1. Oh, 1. 1 means d sine theta by d theta is 1 when theta equal to 0. This proves that when theta equal to 0, if I move along theta axis, x-axis, equally it is moving in y-axis. It makes 45 degree at that point. Can someone believe it? Means sine theta curve, this curve is there, and at angle 0, if I draw a tangent, I can draw tangent, right? Every moment tangent is different. When it is pi by 2, tangent is 0 because it is parallel to x-axis. There is no change in theta, sine theta. So cos 90 degree is 0. But when theta equal to 0, cos theta is 1, means d sine theta by d theta is 1. This proves that x-axis and y-axis, it is changing in same fashion, 1. This proves that it when if I have a straight line, when if I move 1 unit change in x-axis and there is only exactly 1 unit change that is seen in y-axis. If this is happening like that, this straight line is making 45 degree. In that way, so this proves that, I believe it's all right. So this proves that if this is sine theta curve at origin, if I draw a tangent, then it is exactly 45 degree. Then this tangent is becoming lesser. And here it becomes parallel. When it is less, means you grow more in x, and it will, if you grow in x, whatever amount is, it will grow less in y. The change in y will be less for the change in x. If you move 1 unit in x at any point, y will shift less than 1. That's why that is the d sine theta by d theta is cos theta. Cos theta is maximum when theta equal to 0. Means d sine theta by d theta is changing maximum, that is 45 degree. After that, cos theta is decreasing time by time. If it is decreasing, means d sine theta by d theta is decreasing when theta is growing. Means for 1 unit of change at any moment that is not 0, then the change in y that is seen at that moment is less than 1. This is d sine theta by d theta. Anyway, now we are trying to calculate the differentiation of sine theta with trigonometry. So we have calculated differentiation integration of sine theta with trigonometry. Now let's calculate differentiation of sine theta with trigonometry. So same fundamental we will use what we did last time. Why I am doing this much? I would have moved to other topic, but idea is that more and more you churn something, it will be more settled in the brain. So that is the concept. Now consider that this is x-axis. This is x-axis and there is a radius. Same thing I am repeating. So this is x-axis and there is a radius that is moving along the circle. And at one moment it is at angle theta. At that one moment it is at angle theta. If I draw a triangle, then this is the point their angle is theta. This point, I'll draw a straight line and this line height is h. This is radius and this angle is theta. Okay, then at this point, if I draw a straight line, the height is h. Sine theta is h by radius. Pretty clear, right? Now, from theta, I moved delta theta. This is theta angle with the x-axis. I moved delta theta. Now net angle is theta plus delta theta. This is the first point, this is the second point. Second point, first point. If I connect this point, then it is a straight line. If it is a straight line, from this point, if I draw a line horizontal to x-axis, this is a straight line. This line and this line, if I connect from here, it is a straight line. It forms a triangle. Okay. So first triangle is x-axis and radius. First triangle is x-axis and radius. Height is h. Height is h. Next triangle is from here, there is a 2 point connecting 2 point of the arc. This point and then there is a perpendicular parallel to x-axis, okay, and one more line. This is delta h. Delta h because this point the angle was this point the angle with the x-axis was theta, and when it moved like this angle is delta theta. Because of the delta theta movement, height changed. Then earlier height is h. Now this is the arc of the circle. Then there is a slight change in h. That is this delta h. So this is delta h. This is the point connecting two ends for which the angle is delta theta, and this is some line. Okay. If that is the case, then how we calculate the kind of differentiation of sine theta? What is d sine theta by d theta? What is sine theta? So sine theta, if this is x-axis and this is the radius, if this is x-axis, this is the radius, this angle is theta, then this is the h, height. Height by radius, that is the sine theta. D sine theta by d theta, we are trying to calculate. Sine theta is h by r, where r is constant, radius is constant. So radius is moving like this. Radius is moving like this. This is theta angle, and then it is moving again delta theta. So from here theta to theta plus delta theta, this much arc it is changing because of delta theta. Earlier the height was h, Now here the height will be changed in h because of delta theta movement. This height change, this difference in the height because of the delta theta movement is delta h. Okay, there are two triangles. One triangle we can see. This is the one triangle. So one triangle we can see. One triangle we can see. This is one triangle. Okay, and this point, and then it is moving delta theta. Then this is the arc, and length of this arc is r d theta as per the fundamental of circle. This is r theta. Now this point, and if from here I draw a parallel line to x-axis, from here I draw a vertical line. Now this point, one line, this is one line. This is a change, that is delta h. Delta h received because someone moved delta theta angle. Because of delta theta angle movement, the height delta h height was received. Delta h, this line connecting and this line. So from this line, that is the r, that is r d theta, and I am connecting to these two points like this. So there are two triangles. One triangle is the bottom triangle, that is because of angle theta. This is the where height is h. Now there is one vertical triangle. So this is bottom triangle. This is bottom triangle, and this is the height h. Okay, if that is the case, then there is another triangle. So this is h, then this is delta h. If this is delta h, then there is another triangle that forms. This is the radius that forms because we change delta theta from here. This is one line, and there is a this line, and this line. It forms another triangle. Please watch previous video that if this is a new triangle, if this is a new triangle which height is delta h, this is a new triangle, then this angle is theta. Back, this angle is theta, this angle is theta. This is the kind of, we have demonstrated very perfectly in the past video. So this angle is theta. Why this is theta? Because this angle, this full angle, this is a straight line, full angle is 180 degree. If consider this angle is alpha, I don't know what this angle is. This is alpha. Now this is the radius. Okay, and this angle is theta from the previous triangle. These are two triangles, one triangle in the base and another triangle at the top. This angle is theta, and this is the arc. This is the arc where it arc, and this radius moved like this, and this is delta theta. If this is delta theta, then this arc is r d theta. Since delta theta is very small, I can consider this arc is same as this line. Then this line length is r d theta. In that case, what is this angle is? So if this angle is very small, this is like a tangent to the arc at that point. Though it is not a tangent because we are connecting 2 points on the. If I connect any 2 points on the circumference of a circle, certainly that will not be tangent at any point. But we considering delta theta is very small. If that is the case, then 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 we are saying this full angle is 180 degree. That is alpha plus 90 degree, because if this is tangent at that point, this angle from radius it is 90 degree, and this angle same as lower triangle. This angle and theta angle and this 90 degree is 180 degree. If I equate this, then this angle is common. This is 90 degree, then this becomes theta degree as it is theta degree. If this is theta degree, then cos theta is delta h by this line, that is delta h by r d theta. So now d sine theta by d theta is nothing but sine theta is h by r, that is sine theta. Dh by r by d theta, that is nothing but dh by r by dh into dh by d theta. D of h by r by d theta is nothing but d of h by r by dh into dh by d theta. If that is the case, then dh by r by dh is 1 by r. 1 by r I can keep outside. Now I have to find dh by d theta. But now I know cos theta equal to delta h by r delta theta. So dh by d theta is r cos theta. If that is the case, then net becomes 1 by r cos theta, r gone, theta. Differentiation of sine theta is cos theta. Okay. Now we have talked in detail what is caveat here. The caveat here is that if this is the if this is the if this is the if this is the a kind of x-axis, and this makes theta angle from x-axis, okay, then if I draw a tangent at here, this is the actual tangent 90 degree from the radius, but we are drawing taking 2 point that is on the circumference only, because we moved delta theta. If we move delta theta, then 2 points or the circumference that we have connected, but actual tangent is like this. Actual tangent is like this. Okay, so this is angle theta and actual tangent is like this, but we took a line that connecting 2 points that formed by radius delta theta. Now this angle of the movement what we are seeing is delta theta by 2, that we have proved it, delta theta by 2. If that is the case, then what if, first of all, what is if I have a radius, any radius, if I have a radius and radius moves delta theta, then from this point and this point, there is a connecting line like this. The arc length is r delta theta. True. What about the length of the line that is connecting these 2 points? Okay. So it is something like that we have talked. So it is something like if this radius and this is the radius of the circle, this is the arc. What is the length of this line? If I take another line in between, that is theta, this full angle is delta theta, this is delta theta by 2. Then this length by this length is the sine delta theta by 2, perpendicular by hypotenuse. So sine delta theta by 2, if this full length I am trying to calculate, that is d, then this is d by 2. D by 2 by r, d by 2 by r, or d by 2r equal to sine theta by 2. So d equal to 2r sine d theta by 2. Sine in braces d theta by 2 braces close. That is d theta. I mean that is I'm sorry. So that is d. D equal to 2r sine d theta by 2. That is the length. So one thing. Second thing, we said that at any moment if angle is theta, if any moment the angle is theta, then at that point if I draw a tangent, this is this line. But at that point if I go beyond and beyond and take another delta theta, then these are the 2 points. Then this is the line that is connecting 2 points, where a tangent is this. So this proves that there is a delta angle. So when we talk about theta there are two triangles we are talking about. One triangle is at the bottom, where angle is theta, okay, and height is h. Now it moves delta theta. If it moves delta theta, then these 2 points connecting one line comes into the picture. And this is the line. Then there is another triangle on top, that is this line that is connecting these 2 points. This is the line perpendicular parallel to x-axis and new height. This is delta h. Okay, the base triangle is this. This is the radius, this is the base, and this is h. An upper triangle is delta h, and this is the line. Now if this line, instead of taking this line which connects 2 points that belongs to delta theta angle with the center, from here at this point, that is the circle, okay, if this is the circle and these are the 2 points, at this point if I draw tangent on this circle, then the tangent will hit like this, okay, where this angle is alpha, the new angle it is forming is alpha, and this triangle. So this is actual tangent. This is a line connecting 2 points, and this is delta h. This angle is theta, not the full angle is theta. Full angle is theta plus alpha. Full angle is theta plus alpha. So actually cos theta plus alpha equal to delta h by whatever 2r sine d theta by 2 is coming. Then we calculated alpha, that is little shift is there, that is nothing but d theta by 2 only. That we prove, like if I have a d theta, if I consider that this is r, this is r, angle is delta theta, d theta, then there is a line like this. Okay. Now there is a tangent like this. If this is a circle, these are the radius, and this is a circle. This is something like this. Okay. I mean, this is at center. So this is like this. Now, these are 2 points on the circumference of the circle. The line that is connecting is a line, okay. The length of the line we have calculated, that is 2r sine d theta by 2, where this angle is d theta. Consider these angles are same now. Okay, this angle is x, this angle is x. So x plus x, 2x plus d theta is 180 degree. Now consider, if I am taking a tangent at this point, this tangent is perpendicular to the radius at this moment. Okay, and this angle is extra angle that we are saying, that is alpha. Same thing, right? That is alpha. So if I take this, okay, if I'm drawing line, that we will see this angle is alpha and 90. So alpha plus x is 90 degree, because that is tangent. Alpha plus x equal to 90 degree, 2 alpha plus 2x equal to 180 degree. If I subtract, then it becomes delta theta equal to 2 alpha. Alpha is equal to delta theta by 2. Okay, how I did is, we are taking same thing, right? If this is the first point, this angle is theta, and this is delta theta. This is the arc of the circle. So in that case, if this is one point, if this is the line connecting these two ends, then at this point this is the tangent. If that is the case, then this angle, whatever we are seeing, this angle is alpha. Okay, and from here, this angle is theta with the delta h. This height, what we are seeing in my hand, this height is delta h. And from here, we draw a triangle. This height is delta h. And this tangent line, this is theta. And this is 90 degrees. This is what we calculated. This angle is extra alpha, that is delta theta by 2. Okay, if that is the case, then cos theta plus delta theta by 2 equal to delta h by 2 or sine delta theta by 2, because that line connecting the length is sine delta theta by 2. Or someone can calculate if this is the line connecting 2 points with the delta theta, then this is the tangent at that point. If this angle is theta with the tangent, then what is the length of this tangent that is hitting this? This is a triangle. We said that upper triangle. I take upper triangle, then this is the line that is connecting 2 points, and this line and this line. Now this is delta h. Now if at this point, if this is the tangent, then it is going to touch this line. If that is the case, then what is the length of this point? Because this angle is theta. Cos theta equal to delta h by this new line, or cos theta plus delta theta by 2 equal to delta h by this line length, that is 2, or sine delta theta by 2. If that is the case, then someone has to really find delta h by delta theta with this equation. That will be perfect. But anyway, as per the new fundamental in calculus, if it is converging, if delta theta tends to 0 and it is converging to some particular value, we take it. So cos delta theta plus delta theta equal to delta h by 2 r sine delta theta by 2. When delta theta tends to 0, then sine delta theta by 2 will become delta theta by 2, because at delta theta equal to 0, sine is exactly sine this sine, when delta theta equal to 0, then sine delta theta becomes delta theta. I mean, this is the approximation. If that is the case, then it becomes delta h by r, delta h by r, delta theta. 2 delta theta by 2 cut down, and cos theta plus delta theta becomes cos theta only, because delta theta tends to 0, has no importance in cos theta. Okay, if that is the case, then cos theta equal to delta h by r delta theta. Same thing it would appear. But someone can try calculating this in bigger terms. So this is calculation of differentiation of sine theta with the trigonometry rather than first principle, that is sine theta plus delta theta minus sine theta by delta theta. Okay, what is next invention? Next invention is, can we calculate, how we calculate directional derivative along a particular axis? Can we calculate directional derivative along a particular vector? Directional derivative along a vector u. Okay, what we calculate? Generally, if I have y equal to fx, then dy by dx we calculate. Knowingly, unknowingly, we are trying to calculate directional derivative along I vector. I is x-axis. Then what is directional derivative along x-axis? That is dy by dx. So this is x-axis, this is y-axis on xy plane, x-axis, y-axis. If I have a function on xy plane y equal to fx, then dy by dx, dy by dx is nothing but when, or this is x-axis, this is y-axis. Dy by dx, if I move 1 unit from x-axis, how much y changes? dy by dy by d dy by dy by du, dy by d, instead of x-axis, take any on the xy plane. This is x, if this is x-axis, this is y-axis, this is xy plane. On xy plane, this is I vector, x-axis is I vector. Consider this is u vector. This is j vector. Y-axis is j unit vector. X-axis is I unit vector. Consider any vector u. Now what is change in y fx I see along u vector? Along u vector means, if at this moment, if I take any point on u vector, what is the y? And if I move delta u or 1 unit in u at that moment, what is change in the y that we see? dy by du. Earlier we had dy by di or dy by dx. What is dy by du? What is dy by dy? Dy by dj. Change in y when we change along the j vector. Change in y when we change along I vector. Change in y when we change in u vector. So that is nothing but the kind of gradient of the algebraic equation dot product with the unit vector along it. That is the result. But we will see both proof. The proof that is available in the book and proof that we are considering. Mind blowing. Trust me, it would be mind blowing. So that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. So we will see directional derivative along any vector, not only I or j, how it brings change in y when we change 1 unit along that vector, dy by du rather than dy by dx or dy by dy or dx by dy. So that we will see.